Dear students, let us start the revision of 6th semester paper 7 physical chemistry. I am Sanaji. Next, here chapter 2 nanomaterials and polymers. First one is polymers. Schrödinger introduced the term macromolecules to characterize substances with molecular weight greater than 10,000. These substances are formed by the large or giant molecules whose dimensions falls into colloidal range. Hence, they are also called as a molecular colloids. Their name is, he called these molecules under the name macromolecules. Macromolecules are defined as giant molecules formed by large number of small structural units joined by a covalent bonds, and their size falls into a colloidal range of 10 to 10,000 angstrom units and molecular weight greater than 10,000, also called as molecular colloids. First of all, polymers. Polymers are also a class of macromolecules. The polymer is defined as a very high molecular weight compound composed of a large number of one or more small molecular units which occur repeatedly and join together by a covalent bonds. Through a covalent bonds, the smaller repeating units are smaller molecular units join together to form a big molecule of high molecular weight. Those molecules or those compounds are called as polymers. These repeating units are called as monomers. These monomers are small molecular weight simple compounds from which polymers are prepared. Next is polymerization. The process by which small monomer molecules are linked to form a big molecule is called a polymerization. The process of formation of polymer by a monomer is called polymerization. Example for polymers is natural polymers, starch, cellulose, proteins, natural rubber, synthetic polymers, PVC, Teflon, etc. Classification of polymers. Polymers are classified on the basis of different categories. They are classified into different groups. First one is based on origin of polymers. They are classified into, first one is natural polymers. Naturally occurring macromolecules are called natural polymers. Example, natural rubber, proteins, starch, cellulose. Natural rubber is having isoprene units. This is a polymer structure of natural rubber prepared by the monomeric units 2-methyl-1,3-butadiene. After the formation of polymer, double bond shifts to here, this position. Synthetic polymers, synthetically prepared are man-made polymers, PVC, polyvinyl chloride, polyester. These are the two classifications based on origin of polymers. This is the preparation of PVC from vinyl chloride. You can mention only example. Based on mode of formation or polymerization, they are classified broadly into three categories. One is addition polymers, addition of two or more monomers, and all the monomers are also present in a polymer. Such polymer is called addition polymers. Example, PVC, Teflon, polyethylene. Here, tetrafluoroethylene monomers are added together in the presence of ferrous sulfate, hydrogen peroxide in order to form polyfluoroethylene Teflon. Here, all the carbon atoms and fluoride atoms present in the polymer, that is addition of all the monomeric units, all the atoms in the monomeric units. Condensation polymers. When polymer is formed by the condensation of monomers, it may be a same monomers, or it may be two different monomers with the elimination of simple molecules such as water or alcohol, etc. It is called condensation polymers. Example, nylon 6 and nylon 6,6 are the good example for condensation polymers. Here, preparation of nylon 6,6 in the presence of adipic acid and hexamethylene diamine undergo condensation on heating with the elimination of water simple molecule with the formation of amide bond. Nylon 6,6 is formed. Condensation takes place between the two monomeric units with the elimination of simple molecules. Third one is copolymers. These polymers are produced by the polymerizing two or more different monomers. Consider the polymerization of monomers A separately and polymerization of B separately. Those individual polymers are called as a homopolymer. That is, n number of A atoms combine in order to form A polymer, that is homopolymer. n number of B molecules or atoms will join together in order to form B homopolymer. These individual polymers will join together in order to form this AB heteropolymer. Each gives homopolymers, but when A and B are polymerized together, that copolymer is formed, that is the copolymer. Here the monomeric units are alternatively arranged, AB like this, then it is a alternating copolymer. If they are randomly arranged, then it is a random copolymer. Example for this copolymer is Vignan. Example, this is the preparation of Vignan from vinyl chloride and vinyl acetate. Vinyl chloride and vinyl acetate group undergo polymerization in order to form Vignan. Third one is, based on their molecular structure, they are broadly classified into 4 categories. First one is elastomers, highly elastic in nature. Natural rubber, example. Fiber polymers, fiber-like structure polymers, example polystyrene. Synthetic silk is a best example for fiber polymer. Also nylon 66, this is the preparation of polystyrene from styrene. Free radical vinyl polymerization mechanism. Third one is thermoplastic polymers. Polymers which become soft on heating and harden again on cooling are called thermoplastic polymers. This behavior is because of weak attractive forces between the polymer molecules or monomeric molecules present in a polymer. These forces are easily disrupted on heating. Example PVC, as you all know that polyvinyl chloride PVC pipes, example, they can easily become soften on heating and easily become hardened on cooling. Fourth one is thermosetting polymers. The polymers which become hard on heating but cannot be softened by cooling, they are called thermosetting polymers. Example bakelite, phenolic resins or any resins. As you all know that bakelite can be used in a cooker handles, pressure cooker handles. After continuous heating they become hard but will not regain a softness on cooling. After every use of repeatedly use of that handles, they become wasted because they will not soften on cooling. That is thermosetting polymers, any resins. Here this is the structure of bakelite. This is the structure of bakelite. This is a 3-dimensional or network-like structure. Next is, based on modes of linking and arrangement of repeating units. Linear polymers, linearly arranged, a straight chain arrangement of monomeric units, PVC, natural rubber and high density polyethylene. Non-linear are branched polymers. Here when repeating units exist in tri and polyfunctional, but in linear polymers there is only a bifunctional, but here tri and polyfunctional functions may be a tri and polyfunctional, two or more than two functional exist in a non-linear or branched polymers. Low density polyethylene or carbon rods. This is the structure of low density polyethylene, example for branched polymers. Third one is network or cross-linked polymers. Polymers behave 3-dimensional network, as you all already know that structure of bakelite or silica structure. They are the network-like polymers or cross-linked polymers. The structure is like this. These are the classification based on the arrangement of repeating units. Linear, straight line structure, non-linear or branched, at least one branching may exist, and network, here 3-dimensional structure or cross-linked structure. Next, here you have to mention classification with explanation and with suitable at least one example. You have to explain the classification of polymers in detail with example. This is the classification of polymers. In examination there may be a question arise, explain the classification of polymers with suitable example. You have to mention all the types and explain in 1 or 2 sentences and give suitable example. Next is molecular weight of polymers. The molecular weight of single macromolecule will be always equal to the molecular weight of the repeating smaller units multiplied by degree of polymerization. Degree of polymerization is number of monomeric units and their molecular weight. Their product gives the molecular weight of polymers. Always a polymer is made up of different types of monomers. The monomers may be of same or not be, or may not be a same size or may not be a same length. Hence we have to consider average molecular weights of monomeric units in order to consider the molecular weight of polymers. Hence we have to consider average molecular weight for the macromolecules. There are two types of average molecular weights exist for